Now, the other thing, the other thing that's due.
Silent mean that, what is the in generation, what does the category silent mean?
The oldest.
They'll talk, oh, sorry, that's in part 3 of my thing. The silent generation are basically people that are 60 years or older. World War II generation, basically.
Okay.
So, at any rate, are we recording?
Yes, as you are.
It says we are. Okay. All right. So I put some fake names in here. Go ahead and put your names in here of your group members. Your department is math. I need everybody's email address, real email addresses. This is going to go to the IRB, and it has. And they are
not a UVU email. Is that what you're saying?
You can use a UVU if you want. I don't care what you use here. But they need to be able to get a hold of you in case there's a problem with your application. We need phone numbers of everybody's group members, not just the leader. Math 1040, this is summer 2019, okay? Now, here's the deal. You need to give me enough information so that the IRB knows what you're doing. If you want to copy and paste from this other form here, that's fine, but you need to have the question included. You need to talk about you're going to do a simple random sample and a systematic sample and a voluntary response sample and all that other stuff.
You just need one per group?
I only need one per group. I need everybody's phone numbers and I need everybody's email addresses here. So just erase what's there. Describe the risks. Now, the idea here is when you're calling people, you know who you're calling because it's in the phone book, right? You need to tell me how you're going to safeguard that information, okay? This is going to go to the IRB, and so you need to talk about this. So the idea here is you need to send this to me and get my approval first. If you get my approval, you'll get IRB approval.
So how to protect the identity of those surveys?
Of the people that you're calling. Or if you do a Facebook poll, how are you going to protect their identities as well? Because you'll know they're your friends probably, okay? So the biggest problem is people skimp on the describe, and it says don't skimp on details. You're still going to skip, some of you. Quit skimping, okay? Give me way more information than I need. I'd rather have that than not enough information. Because if you don't give it to me, I'm going to send it back to you and you're going to have to redo it. So give me all the information the first time. Make sure you can tell me how you're going to handle your data. Now, so you've got your student signature, your student name down here, your city number. So you should have your student number and then put your date on here. Let me show you how you're going to sign this. If you use Paintbrush, okay, so you can use the pencil here, use your mouse. Okay, that's good enough. Now you're going to use this box. You're going to copy this, and you're going to paste it right there. And if it's too big, you can resize it, just like that. You'll put in here Rick Bennett. You'll put in your city number, which is 1, 2, 3, 4, 5, 6, 7, whatever the number is, and then you'll put in today's date, which is 7/8/2019 or whatever. Does that make sense? Mm-hmm. I need everybody's signature. That's the other big thing is people don't get signatures, okay? If you've only got 3 people, you can delete the rest of those there. That's fine. Remember, so some other things. It's conducted only for the purpose of receiving a grade. We're not going to publish this outside the university without prior IRB approval. We are not going to use minors, so how are you going to weed out your minor children on your Facebook page? Think about that too. Risk is minimal. We're just doing a survey. No audio or videotaping. That's a big deal. We're not going to use any deception there. Okay? Then you can see I've got my signature there. I will sign it. I will send it to the IRB. I only want to send them together. So I think for the most part, this is pretty easy. Do you think you can get this done by tomorrow before class? Okay. This is what needs to be submitted. Actually, if you submit this, then I'll have everybody's, put your names here. I'll have everybody's names, okay? You Usually takes about a week to get approval from IRB, so don't collect any data yet. Hopefully by Monday, if you all do it right the first time, please do it right the first time. I always have to send some back because they don't give me enough details. Give me details. Then you can start collecting data on, say, Monday. Okay? That will be due at the end of class. Last 1 or 2 days of class, you guys will teach class, and I'll sit here and be the student. Okay?
Can you point one more time to the paintbrush you used to sign?
So if you're using the Windows thing, if you type in pbrush, and then this little thing here is called Paint, and then you can draw on here whatever you want to do. Okay? I don't know what it is in the Mac. Okay? Any questions on that? All right, so that's due tomorrow. So make sure that you give me enough details here and you get everybody's email and everybody's phone number, okay? That will be useful. Okay? All right.
Only one person in each group.
I only need one per group, okay, on Canvas. And I will give everybody the same thing. Question?
Then you want the other form as well, or you just want that one because that one have all?
You know, this will have everything. This is the only one I really need.
Okay.
Okay?
So when we do the Facebook, social media, so should we protect our people, or how that gonna work? Like the people who say yes, no?
So generally what I will say is I believe either Qualtrics or SurveyMonkey are free.
Qualtrics is free if you're a student.
Okay, so Qualtrics, I think SurveyMonkey is as well. Qualtrics or SurveyMonkey are free. So what I would do is I would say, hey friends, would you please fill out this survey? You have to be at least 18.
Oh, we're good.
I hope so. You have to be at least 18. And to do the survey, click this link and it'll take you to the SurveyMonkey for the Qualtrics. Oh my gosh, I hope I make it through class today.
Maybe I'll get some invited.
Oh, man.
If this wasn't recorded, I could give you some things.
All right, so any other questions? Make sure you're collecting their age. I would like to see a good histogram of their ages to see if your data are normally distributed. All right, and speaking of normally distributed, that's what we're going to be talking about today, is the normal distribution, okay? Oh, by the way, I should show you, well, I'll show you after class maybe. I was going to show you the breakdown of grades. And then I was going to tell you all you're not normal. All right, so you've all learned how to do the, how to calculate the standard deviation by hand, right?
Yeah.
It's a lot easier with the stdev function, right? All right, so you're probably wondering, why did I make you figure out the standard deviation, right? So I'm going to answer that. We're going to cover chapter 3, which is normal distribution. Okay, this is the most common type of data. It was discovered by a man named Gauss. It's also called the Gaussian distribution. Okay, now here's a funny story. So apparently Gauss had a mathematical rival and he didn't want to call it the Gaussian distribution because he didn't want to give Gauss credit. And so he said, oh, that's just normal data. And so it kind of stuck, and that's why we call it the normal distribution. But technically, it's called the Gaussian distribution, okay? It's probably the most important distribution in statistics. Because other distributions can be simulated by the normal distribution.
Simulated?
Simulated, right. Okay. So, some properties. Number one, area under the curve is 1 or 100%. Number two, the median equals the mean in a true normal distribution. Number three, the curve is symmetric. And number four, two most important numbers are the mean and standard deviation. If you know those two numbers, you know the curve. Okay? All right, we also have, let's see, I think that's a little, there we go. I think that'll be easier to see on the video. Maybe I'll use a darker pen.
What does the first one say?
Here,
Area under the.
area under the curve is 1 or 100%. I just dropped my lid.
Want me to grab it?
Yeah, I didn't even see it.
Behind you.
Oh, there it is. Yeah, thank you.
You're welcome.
Oh, I feel like a cripple.
Hey, don't worry about it. I'm the same way.
Oh. All right. See if this blue is a little darker. Okay, we also have what's called 68, 95, 99.7 rule, also called the empirical rule. Okay? And you're probably all familiar with the bell curve. Okay? This value here is the mean. And when we go out, one standard deviation, okay, we would expect 68% of your data to be within one standard deviation. Okay? 68% of the data within one sigma or one standard deviation. Two is 95% of your data within two standard deviations. Okay, so if I go out here, 2 sigma, I would expect 95% of my data. And then 99.7% of your data are within, and I'll bet you guys can guess, 3 standard deviations, okay? So if I go out here, 3 standard deviations, I would expect 99.7% of my data, okay? And so, this is why we need to know the standard deviation, okay? All right, let's do an example. Find the values for 68, 95, 99.7 rule. If the height of women are 65 inches tall with standard deviation of 2.5 inches.
So the
Okay.
mean is.
Say that again?
The mean of the height of the women is 65 inches.
Right. Okay. So, based on this information, what should be that value right there?
65.
65 inches, right? Okay, and if I go out one standard deviation,
7.5 on the top.
so this would be 67.5, and this would be 62.5. I would expect what percent of the women to be between 62.5 and 67.5 inches tall?
68%.
I would expect 68%. Okay? I'll use a different color here. How tall should I expect 95% of the women to be?
70.
70 to what? 60? 60 to 70. I would expect 95% of the women. And if I go out 3 standard deviations, what is this value here? Be 7.5 and 2.5. I would expect 99.7% of women, right? Okay. Now, let me ask you this question. There's going to be a lot of homework questions like this. What percent of women are 60 inches tall or less?
No, so 60 inches or less. So that's
60 inches or less.
to the left of the 60. So
Okay.
you're going to highlight.
So from here to here, we've got 95%, right? So how much do we have here and here? So if I've got 95% in the green area, how much do I have outside of the green area? 5%. And I've got half of it here and half of it here, right? So what percent is here? 2.5%. Okay? 2.5%. Does that make sense?
Yep.
How about this? What percent of women are greater than 67.5 inches? Okay, that's the blue area I've got here, right? How much is in the blue area?
68%.
How much is outside the blue area? 100 minus 68, right? 100 minus 68 is 32. How much do I have on each side? Half of 32, right? So that would be 16%. 16% of women are greater than 67.5 inches tall. Does that make sense? Okay. What percent of women are less than 67.5 inches tall?
$84.
84, right?
Now we just take the data from last
It's just the opposite. That's the complement of this, 84%. See that? How about one more? What percent of women are 62.5 to 65 inches tall?
What percent of women are 62.5 to 65 inches tall?
What'd you say? How'd you get 34%? It's half of 68, right? 34%. Okay? Do you see that? Are you gonna ace my test?
The written part, yes. The computerized part, no.
Did you say 34%? Is that
34%, that's correct.
Test the please.
Yeah, we gotta worry about the quiz tomorrow.
Like,
We'll only worry about that.
skipping steps.
All right. Let's do another problem. All right. There's a T-scores have a mean
Under the curve is 1.
of 500 and standard deviation of 100. James scores 600.
Man, those guys have terrible SAT scores.
What percentile does James score? Is this a good score? I'm going to show you two ways to do this. We'll stick with the 68, 95, 99 rule for now. So James, what do you think? Is that a good score?
In reality, no. But according to this problem, it might be.
Are you James?
I'm just trying to catch up.
Okay. I need to introduce to you a new phrase.
500.
You've heard of the phrase WWJD, right?
Yeah, who wants jelly donuts?
What would Rick do?
Oh, there we go. We're going to have a new phrase, WWRD. What would Rick do? And what would Rick do? He would draw a picture.
Oh.
Okay? So James, can you help me draw this bell curve here? What's this value here?
500.
Is your name James?
Oh, my bad.
What are we going by, 600? This is the night score. I mean,
The CT scores have a mean of 500 and standard deviation of 100, right? So the mean score is
60.
the mean score is 500, right? Okay, 500. And how did you score?
600.
You scored 600, so that's better than average, right? So you're better than average.
On the top of the 60.
It depends.
Okay? What's the standard deviation? It's 100, right? So you are exactly one standard deviation above the mean, right? Can you tell me, based on what you've already learned in this class today, what is the area to the left of that? Do you know?
What do you mean, like the?
This black area that I just highlighted.
The,
We know between 400 and 600, what percent of your data is there?
saying,
We know that 68% is between 400 and 600, right? And if we split that in half, how much is on each side? What's 68 divided by 2?
34.
34 here and 34 here. What percent of people scored less than 500? Nope. 34 only goes to the 400. I'm talking about all the people who even go to 0 on the SAT. Nope.
Well, it would be 50.
If 500 is the mean, it's also the median, right? So that's 50%, right? So 50% plus 34% means you scored in the 84th percentile, right?
That means you killed it, bro.
You did better than 84% of people.
Oh.
Ah.
Give me money for
Does that make sense?
bro.
Does that make sense? Are you going to be studying with Jordan tonight? I think he knows what he's doing. You should listen to him.
I don't know what Jordan is.
Okay, well, it's changed. Okay, does that make sense? All right, we're going to do another example here.
But in actuality, that's a terrible SAT score.
It is 84th percentile?
No, I meant like if it was actually 600 instead of if we didn't have everything else, it'd be a terrible score.
That should be like 1,000 for your name.
Yeah.
I think the best you can do is 800, 820 or something, isn't it?
No, 1600.
Oh, is it?
I don't know.
Okay, let's say that the ACT has.
I did terrible on this test.
Oh, dude, I killed this test, dude. But I took it when I was like a sophomore in high school, and I never took it again. I was taking like 3 math classes at the same time.
ACT has a mean score of 18 and standard deviation of 6.
What?
Let's pick on Alex scores 21. Who did better? Alex or James? Okay. All right, now the problem is if we were to draw this, okay, what is the mean, Alex?
Mean is 18.
18. Standard deviation is
6.
6. So this is 24 and this is 12, right? Now it was nice that James was right on the standard deviation, but the problem is Alex is not. Alex is at 21, and that's not one of our nice boundary points, right? Okay. So I'm going to show you a new equation. Any normal distribution can be converted to the standard normal distribution, which has a mean of 0 and standard deviation of 1 with this equation. And the equation is z equals x minus mu over sigma. Now, I know that's kind of low on the board.
X minus mu?
X minus mu over sigma. Okay? Now, there's going to be later on in the semester, I'm going to give you another formula that looks very similar. It's not in this chapter, but I think it's a better formula. I'm going to explain why. There's going to be another formula, z equals x bar minus mu over sigma over the square root of n. Okay? You can see that those two equations are very similar. And what's going to happen is you're all going to tell me, I don't know which equation to use. And I'm going to say, always use this one. Okay? Now, one way to think about this is z. I often refer to the normal distribution as the z distribution. Z equals your data minus your mean over your standard deviation over the square root of your sample size. Okay? If you use this equation all the time, you'll never get it wrong. Okay? And so let's go ahead and use this. Okay? So what we're going to do is we're going to say Z equals, okay, Alex, what is the data in this case?
So we're using the second equation?
We're going to use this one, but you can do, the chapter uses this one, and I'll tell you what the difference is. How many Alexes are there? There's only one. There's only you, right? Okay. This equation is exactly the same as that one if n is always 1, right? Because the square root of 1 is 1, right? So these are the same equation. Okay. So in the future, so if the problem doesn't tell you your sample size, assume it's 1. And if it does tell you your sample size, then just use it. Okay. So this is the better equation to use, but this is the one that they give you in this chapter. Okay. So the data is 21 minus the mean, which is 18, divided by the standard deviation, which is 6, divided by how many Alexes are there? There's only 1, right? So 21 minus 18 is 3, divided by 6, which is 0.5, right? So you can see as we look at this, James was a full standard deviation above the mean, whereas Alex is just a half of a standard deviation. Now the standard normal, and this is one of my favorite, I'll have to put this on the quiz tomorrow. I'm going to ask you what the mean and the standard deviation of for the standard normal distribution. And some of you are going to say, I don't know, you didn't tell me. Okay? And I will say, yes, I did tell you. The mean is always 0 and the standard deviation is always 1 for the standard, and that's the key word there, normal distribution. Okay? So what happens is I can take both of these two different distributions. Notice they have very different scoring systems, right? This has a mean of 500, this has a mean of 18, but both of them are college admission tests, right? Okay? So I can convert James's score, because the mean is going to be 0 and James is 1. And Alex is 0.5. And you can kind of see that in this case, James did better on this test, right? Okay? But the problem is, it was fairly easy to figure out how James did in relation, but it's not so easy to figure out Alex. Okay? All right, so let's figure out the percentile that Alex did on this. Okay?
Question.
Yes.
What is that little line?
So now we're trying to figure out the
What's the square
percentile
root?
for Alex.
Wait, this?
The
We've got a divide and we've got a square root there.
Oh, you
The
divided by.
data minus the mean divided by the standard deviation divided by the square root of the sample size.
Okay, I see. Okay.
Okay?
On the straight, wasn't really.
In this program.
All right, so I'm trying to remember in your book, who's got your book? Okay? Now, you know what, just for fun, can I scare you guys for just a minute? Okay? Now, in order to figure out the area under the curve to the left of Alex's score here, you typically need to know calculus. But this is not a calculus class, is it? Now, just for fun, this is the scary part, but you don't need to know this, okay? If you wanted to know the area to the left of Alex's score, you would take the integral from negative infinity to 0.5 of e, let's see, 1 over 2 pi sigma times e to the minus x minus mu squared over square root of 2 pi sigma squared. Okay? And that's how you could find out the area to the left of Alex's score.
We'll get extra credit if we do that on the exam.
Yeah, good luck with that. Okay? You need to know calculus to do that, but this is not a calculus-based class. So instead, if you open up your book, in the back, the very back, you've got a standard normal table that looks like this. Okay, right there.
Oh, very
It's
good.
literally the very last page of the book, okay? I'm going to show you guys how to do that. I also got one in Excel, and I think it's going to be easier to use. And so let me share my screen. Except for I need to open up Excel here. All right. Hopefully I can find it easily. Oh no.
You're not signed into Excel.
I'm not signed into my OneDrive. Let me see if I've got it. Oh, I didn't think about this. I'm not in my regular classroom. I don't have access to my files. All right, well, never mind. I can't show you that. I'll have to do that another day. Okay, so I'm going to do my best to show you guys on this video. Okay? So the idea here is, okay, you've got these numbers across the top. Is that going to focus ever? There we go, it focused now. All right, so you've got the numbers across the top, and then you've got the numbers down the side here. So these are your z-scores, and it gives you one decimal. So if we go down here to 0.5, okay, so you've got 0.5 right there.
So 0.5, because that was the standard deviation.
Yeah, and then you can add a second decimal across it out. So Alex is 0.50, right? So that first number there is 0.6915. Do you see that? Okay, hopefully you do. All right, so we can say that the area to the left of here is 0.6915, okay? Now, so Alex did better than 69% of students. So that's still better than average. What would an average student be? What's the area to the left of an average student? 50%, right? So an average student would be 50. So you can see here that Alex scored 0.6915, and actually, we can also figure out James. If we don't use the 68, 95, 99 rule, okay, if we look in here on our thing, if we go to 1.0, yeah, 0.8413. Okay, right there. 0.8413. So this actually, if we want to be more accurate, it's 0.8413. Okay? Does that make sense? All right.
So we need those rules.
So you're definitely going to need the book. I also have I posted the formula sheets? I'll try to post the formula sheets when I get out of this room. Okay. Now let me do one more problem. This is a good one. Actually, we'll do a few more problems. Let's say that toddlers have a mean height of 38.72 inches and standard deviation equal to 3.17 inches. Find the probability that a toddler is 35 to 38 inches tall. Okay. Oh, I already erased my good formula. Okay. But let's pick Bettina to do this. Okay. What would Rick do?
Well, first we draw the standard,
Draw the standard,
Distribution.
well, we're gonna draw a regular normal distribution,
regular normal distribution,
okay?
with the mean of 38.72. And I'll probably have to use my calculator to piece out what happens at
Yeah.
each standard deviation.
So if we go out one standard deviation, it's -3, so that's gonna be 35.57. And at 17, that's 89, 41.89, okay?
41.89.
All right, so that's good enough for what we want to do. So the idea here, we want to know two values that are not on our limits, right? 35 to 38 inches. We want this area here. How do we find that? Any ideas?
We use this formula.
We're going to use the formula. Using the markers here. All right, so what should I do for the formula? It's going to be z equals,
Well, z equals, so you put x as the bar over, so that's the mean, right? So z equals 38.72.
no, x is not the mean. Mu
Why
is,
did you put a bar over the original one? Because doesn't that mean mean? Would you just do x?
it does mean mean, it's a sample mean. Ignore that for now. I put that on there because that's going to be the formula for a future one.
Okay,
But
we're
it
saying
just
data.
ignore it for today.
Okay, so then it would be
It's your data.
38
38
minus 38.72 divided by the standard deviation, which is 3.17 over the square root of n, and n is 1, because it's just one kid.
Yeah, I didn't give you, yeah, right. Okay, so this works out to be a value of, oh gosh, I felt really good this morning. Negative 0.23. Okay, now Sandra, can you do the same thing for the other number?
Okay, it's gonna be 35
35,
minus 38.72 over 3.7. Divided by square root of 1.
okay, and that works out to be negative 1.17. Okay, so what we've done is we've converted this, okay, I'm going to change the scale. So 38.72 now corresponds to what value? What's the mean of a standard normal curve?
0.
0, okay? 38.72 just became 0. This value right here is what? It's negative 1.17, and this value here is negative 0.23. You see that? So we're 0.23 standard deviations away, and we're 1.17 standard deviations away. Does that make sense?
Why negative 1.17?
Because that's the value I got for my z-score here. These two
Oh, I
values.
see.
This becomes here, this goes to here. Okay?
I see.
Does that help? Now, a lot of you people like to miss problems, and you don't draw your picture. But what I'm going to tell you is, if you'll draw your picture, you're more likely to get this problem right. Okay? So now we need to figure out what's the area to the left of negative 0.23. Okay? So as I look at my value here, so negative 0.23 works out to be, so negative 2 is right here. And I've got 0, 1, 2, 3.
So 0.5910.
Let's see. Negative 0.23. I've got 0.4090. That value right there. It's negative. It's on the other page. Okay? Do you see that?
So 0.4090.
So this corresponds to a value of 0.4090. Okay? Now, can you find the value associated with negative 1.17?
Negative 1.17.
Right. I'm not going to give you this one. I want you guys to find it.
0.1210.
Yes, that's correct.
So
0.1210.
is that the z-score? Is that what you're talking about?
So these are the z-scores. These are what we call the p-values. This is 0.1210. Okay? So what this is telling me is 12% is to the left of negative 1. 41% is to the left of there. So how do I find this green area? You're going to subtract. So 0.4090 minus 0.1210, 0, then minus 1 is 8. 39 minus 12 is 27. So 27.8% of toddlers are between 35 and 38 inches tall. Does that make sense?
Can you say that thing you were saying again about the corresponding? You said like 0.4090 corresponds to, so are we doing the z-scores, does that just transfer it all to a standard normal distribution with a mean of
Yes.
0?
Yes.
And how it relates?
Yeah, anytime you use this equation here, it changes it to a standard normal distribution with a mean of 0. And so because so any problem that we do, it doesn't matter what the numbers are, if we use this equation here, can convert it to a standard normal, and then we can use our table in the back of the book so that we don't need to know calculus. Isn't that nice? Who needs calculus anyway, right? All right. Now, the last problem that I want to do is this here. How tall are the top 25% of toddlers? Okay. So another way to think about this is
With the same mean and standard deviation.
same mean, same standard deviation. Okay. So essentially what I've done here, I want this area to be what? This is your top 25%, those are the tallest toddlers, right? Which means the white area is what? 75%. So the top 25% corresponds to the smallest 75%, right? Okay? So in this case, what I'm doing is I'm going to take a standard normal distribution. Okay? I know the mean is 0, but I don't know what this value is. And I know that 0 corresponds to 38.72, and I need to figure out what this value is, right? Okay? So in this case, I'm going to use my table backwards from what you've been doing. Okay? So the top 25% is the same as the bottom 75%. Okay? So you're going to look at this table, and you're going to find where does 75% fit in there. Okay? And so when I look here,
Small numbers down here?
so we're going to look at the 4-digit numbers in here. Okay, and so you can see here there isn't a 75% exactly. There's a 0.7486 and there's a 0.7517. Okay, so 75% is about in between of those. Do you see that? Okay, so what would be the corresponding z-score?
It would be 0.675.
Yeah, okay. So what we're doing here is we're going to say this value now is 0.675. Okay, does that make sense? Now,
So is that the point where, or is that everything? What value is 0.675?
Okay, this 0.675 tells me I've got 75% below it and I've got 25% above it. Okay? So I'm still going to use this formula here. Z equals x bar minus mu over sigma over the square root of that. Okay? But now I know my z. My z is what? That's the value I just found on my table. 0.675. X bar, what's my x bar? I don't know. I'm going to leave that as x bar. Minus mu, what's mu? 3, no it's not.
Oh, the mu, 38.72.
38.72 divided by 3.17 divided by the square root of 1. Okay? So I'm going to do a little bit of math. That's going to go away, right? I'm going to multiply both sides by 3.17, so that's going to cancel. And then I'm going to add 38.72 to both sides. So x bar equals 3.17, that's 0.675, plus 38.72. Okay? So I kind of use this table backwards now. And
So T, did you put T?
Z.
Oh.
Oh, that's a plus. Equals 3.17 times 0.675 plus 38.72. That's just a little bit of algebra. That works out to be 40.86 inches.
40.86.
40.86 inches tall. So the top 25% of toddlers are 40.86 inches tall. Okay? All right, so your quiz is going to be on chapter 3 tomorrow.
Heck yeah.
And it's going to be a lot of fun.
Yeah, it is. I'm
But we're supposed to, in the quiz, we're supposed to use your formula for the Z-score.
You can use either one because that's always going to be one of those chapters.